This is Gail Kovac for Gresham Barlow School District. This is summer school, high school credit recovery, geometry, and learning target number 3. I can identify and transform figures through rotation. So we've talked about transformations. It is changing the orientation or position of a figure without warping the figure at all. We talked about translation, which is a slide. We talked about reflection, which is a flip, and now we're going to talk about rotation, which is like a twist. And for a twist or a rotation, there's a couple of things you need. So imagine putting your finger down on a piece of paper on the table and then just spinning that paper around where your finger hits it. It'll spin around your finger. There's two things that you need to know. Where do you put your finger down? Where is the point of rotation? And then how far do you twist and in what direction? So those are the three things we need. So in the problems you're going to see today, the point of rotation is always going to be the origin, which is 0, 0, right in the middle, right here of your XY coordinate plane. So that's where you would essentially put your finger down to twist this paper around. So we've got our original shape in this problem here on the left, which is BKHP, and then our transformed shape, which is B prime, K prime, H prime, P prime. So before is in black and the after here is in blue. So what we want to do again is to map each point to its transformed point to see what's happened there. So my original point here is B. Let's start with B. And it looks like it has gone over to B prime, which is right here. So there's a couple ways you could do this. It looks like it's gone from here to here in a twisting motion. I've got to figure out in what direction is that and how many degrees of rotation is that. We're going to be talking about rotations in degrees. So it looks like this is essentially, if you look at my coordinate plane here, that took up a quarter of the plane. It is a quarter twist to the right. Right in this direction, like an analog clock hands goes, is called clockwise. If it were going towards the left in this motion backwards, like here, we would call that counterclockwise or against the clock. So here's how we can figure out if it's clockwise or counterclockwise. This is going to be clockwise because it goes in the same direction that a clock's hands go in, an analog clock. And we got to figure out the degrees. Now this is kind of like a quarter turn. I need to know what that is in degrees. So here's what we can do. I'm going to draw a line from my original point B to my point of rotation. And then I'm going to continue it from the point of rotation to my transformed point here. And I've got to figure out how many degrees is this angle here that I created, this angle right here. So if you know anything about angle measures, you know that a perpendicular corner like this is 90 degrees. So this is 90 degrees right here. My square angle, 90 degrees. All the way across like this would be 180 degrees. We've got 3/4 turn is 270 degrees. And then all the way around back to the beginning, mapping back onto itself would be a 360 or 360 degrees. So it looks like in this case, we've got a 90-degree angle here. That's what we're working with. That is a quarter turn. A half turn is 180, 3/4 turn is 270, and a full turn all the way around is 360 degrees. Now you can have measurements or rotations that are less than those four or more than those four. You can have 37 degrees or 68 degrees. But for simplicity in these problems, we're going to be just looking at those quarter angles or 90, 180, 270, and 360. So I have a clockwise, clockwise rotation 90 degrees about the origin right here. So we are going to say clockwise. and this is 90 degrees, and the point of rotation is the origin. So we're going to say about the origin. It goes around the origin. So about the origin. And that is that middle point right at 0, 0 in the coordinate plane. All right, so now let's take a look at this next problem. The first one you had to just say what happened to the shape, and the second one you actually have to do something to the shape. So I would like to rotate this figure now 180 degrees around the origin. So that's going to be 180 is a half turn. Now I notice here that it didn't specify if it needed to be clockwise or counterclockwise. And that's because a half turn in either direction you go is going to end up giving you the same result. Clockwise will give you the same result as counterclockwise, so it really doesn't matter. If it were 90 degrees counterclockwise, that would be different than the original one. Here, counterclockwise would be going instead in this direction. That would be counterclockwise, and in which case your result would be different. If you rotate at a half turn or a full turn, you end up getting the same thing. So let me talk about what I mean here. So we are going to rotate about the origin. So here's my point. This is the point that everything is going to rotate around. That's where I'm putting my finger down on the paper, so to speak. I am going to map each of my original points, J, V, Y, and R, to that point, and then a full 180 degrees to the other side, the same distance. So let's start with point J right here. Here's point J. I'm going to map J to the origin. And this is not very straight. And now I need to go a full 180 degrees from there. So I'm not doing a half turn, a quarter turn. This is where a quarter turn would end up like in this direction if it were counterclockwise, or in this direction if it were clockwise. So I'm not doing that. I want a full 180, which is a half turn, in which case I'm going to continue that line to the other side. I'm going to go the same distance I originally did, like here, B to my point of origin, and my point of origin to B prime is the same distance. So same distance across, it looks like one box diagonally here, and that is where J prime is going to end up. So here's where J prime is right here. It is 180 degrees. That's a full half turn right here. Here's 180. And that's where J prime is going to end up. So let's do the same thing here with point V. I'm going to map V to my point of rotation, and it looks like it went 2 spaces across. I'm going to continue another 2 spaces, so it's kind of like a reflection, but it's at a certain angle. And I continued through because it's another 180 degrees here. Here's 180 degrees. And there is V prime. Let's put this down here, V prime. All right, now we're going to go over to point Y. Actually, let's do point R first. So Y is going to be a tricky one. All right, so I'm going to map R to my point of rotation. Looks like it kind of goes along that J prime route as well. So R is going to be, oh, it's almost through. Almost, not quite, doesn't quite go through. So let's actually count the steps here. So this one goes down 1, 2, 3, and over 1, 2, 3, 4. So I'm going to do the same thing in the other direction though. So let's go 1, 2, 3, 4, 1, 2, 3. I believe R prime should end up right here. Be nice if I had a ruler to make sure I was making nice straight lines, right? But I believe R prime is going to end up right over here. So 180 degrees, and that might not be 180. This looks like I think it's going to be over here instead. Let's see. Does that look like a straighter line to you? I think that looks like a straight line to me now. So I think this one is messed up. I think this is the correct location. So let me erase my other work here. I think this is correct. You want a straight line right through since it's 180 degrees. So I believe R prime is going to end up right there. All right, let's do this last one. Let's see what color have I not done yet. Let's try purple. Here is Y, and I want Y prime the same distance, but on the other side. So right here, and then I think it's going to end up over here somewhere. Over here somewhere. So I think it's going to end up right here. That can't be right. Down and over. I think I messed up something with R prime. Up 3 and over 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. I think it should end up right there. Y prime. So I think my R prime is still a little bit messed up. Gosh, these ones are tricky. All right, let's try R again. So R prime goes over 1, 2, 3, 4 and up 1, 2, 3. Oh no, I think it is correct. Yeah, that is correct. Well, golly gee, I think I got it right. Here is how we can double check if we got it right. I need to reconnect my 4 points, and here's how I think I did get it correct. Y prime and R prime are 1 space apart here horizontally, and R and Y are 1 space apart horizontally, so I think I have done that correct right here. All right, so now let's see. Gosh, this is such a mess now, isn't it? Yeah, these are 1 space apart diagonally, so are these ones, so I think that's correct. And then I've got here and here. Definitely a trickier one, these rotations, even if a 180 degree one is a little bit tricky. So now I need to double check that this looks correct, and trust your instincts because we have experience with twisting things around and they're in different positions, but they're still the same shape. Do these look essentially the same? Now, I wish, again, I had a ruler because it would look a lot more accurate, but I'm kind of counting the spaces between. I'm looking for some like parallelism here. I think I did, in fact, get this correct. This looks like the exact same shape, so they are congruent. They're same distance apart. They're not twisted or warped in any strange way. It's just the whole thing has been twisted around. You can kind of, close your eyes and imagine twisting around and keeping your finger on this center point right here and see if everything looks correct to you. In here, it doesn't tell you to mark any of the coordinate points, so you don't need to do that. We just needed to see this after picture over here. So 180 degrees is a half turn. You just go straight across and keep going. A quarter turn, you'll have to do like a little 90-degree bank like this, a little 90-degree bank. 270, you'd have to go all the way around 3/4 of the way around.